So we got I square equal to integral 0 to infinity e raised to minus s square e raised to minus u square ds du. Now let us see how to evaluate this integral. We have I square. Now what we do is we'll convert this integral in terms of polar coordinates. So what we do is put s equal to r cos theta and u equal to r sin theta. Here e raised to minus s square plus u square varum. Substitution you will get s square plus u square equal to r square. E raised to minus r square. ds du will be r. Let me take the order d theta dr. Ini nammada region of integration nu parayunna s and u both varies from 0 to infinity. That means it's the portion of the first quadrant. Okay. First quadrant in a polar form convert cheyumbo, so radius will vary from 0 to infinity and the angle is from theta is from 0 to pi by 2. So therefore the integral will be integral 0 to infinity, then 0 to pi by 2 e raised to minus r square r d theta dr. Ni theta vich differentiate integrate cheyumbo you will get theta from the limit 0 to pi by 2. So pi by 2 varum. So remaining you will have integral 0 to infinity pi by 2 e raised to minus r square r dr. Now let me multiply and divide by 2. So you will get pi by 4 integral 0 to infinity 2r e raised to minus r square dr. This will be pi by 4 into minus e raised to minus r square from 0 to infinity. That is going to be the value of the integral. So upon giving the limits you will get pi by 4 into 1 minus 0, so which is equal to pi by 4. So that is the required value of the integral. So I square will be equal to pi by 4. Ini namakku vendada I aanu. So the value of the integral I will be root pi by 2. Okay. We started with L of x raised to 1 by 2 eduthappozhanu namakku I nu parna integral vanna. So L of x raised to 1 by 2 was 2 by root p I. So value of x raised to 1 by 2 will become root pi by root p, and we need to find L of root x. So L of x raised to 1 by 2 nu parayna that will be minus d by dp of this we have done previously. L of x raised to 1 by 2 is minus d by dp of L of x raised to minus 1 by 2. So, this is gitti. Ni idinte derivative eduthu kayinal we will get the Laplace transform of root x. So let us take the derivative of root pi e raised to minus 1 by 2. So derivative edukkumbo you will get minus root pi into minus 1 by 2 into p raised to minus 3 by 2. So that is root pi by 2 p raised to minus 3 by 2. So this is the Laplace transform of root x. And again using these results, using this idea we have few more results. So if you take L of xy, that will be minus d by dp of L of y. So if I write L of y to be equal to capital Y, so that is minus dy by dp. And if you need L of xy dash, so L of xy dash should be minus d by dp of L of y dash. Now L of y dash we have seen that is p L of y minus y of 0. So that is minus d by dp of py minus y of 0. So upon taking the derivative you will get now py nu parayna random function of this capital Y is also function of P. So, and the derivative of Y of 0 will be 0. So, you get minus d by dp of P Y. And similarly, if you want L of x y double dash, that will be minus d by dp of L of y double dash. So that is minus d by dp of, now L of y double dash is p square y minus p into y of 0 minus y dash of 0. So that is minus d by dp of p square y minus p y of 0. So this is the Laplace transform of xy, xy dash and xy double dash. And this formulas are used to solve. So for example, if you have a differential equation with such terms in it, so when you solve for this differential equation, so we will use this results. Okay. So let us use this results to solve the Bessel's equation of order 0. So the equation is x y double dash plus y dash plus xy equal to 0. Now when you take the Laplace transform, so you get L of xy double dash plus y dash plus xy equal to 0. So Laplace transform of xy double dash will be minus d by dp of p square y minus p. So here you have y of 0 equal to 1. So in the equation you have the initial condition y of 0 equal to 1 above p into y of 0 ആണ് വരുന്നത്. Then plus L of y dash is going to be p y minus y of 0. So py minus 1 varum. Then plus L of xy. L of xy എന്ന് പറയുന്നത് minus dy by dp. So this is equal to 0. So that implies, so when you differentiate the first term with respect to p, so you are going to get minus p square dy by dp, then minus 2p dy by dp plus y of 0 varum, y of 0 1, then plus py minus 1 minus dy by dp equal to 0. So that gives sorry, here this is 2py. Okay, so upon simplifying you will get minus p square minus 1 dy by dp plus py equal to 0. Sorry, minus py equal to 0 varum. So minus sign will cancel out. So you'll get p square plus 1 dy by dp equal to minus py. So let us now integrate this. So we can use variable separable form to integrate. So dy by y will be equal to dp. So you will have minus p by p square plus, so that is, so upon integrating you will get ln y. So integral of minus p by p square plus 1 dp will be, so put u equal to p square plus 1. So du will be 2p dp. So that will be minus du by 2 u, so that is minus 1 by 2 ln u. So you are going to get minus 1 by 2 ln of p square plus 1. So let me take the arbitrary constant as ln c. So you will get y equal to c p square plus 1 whole raised to minus 1 by 2. Now upon expanding this as a binomial series, so we will have this expansion. So 1 plus z whole power a equal to 1 plus az plus a into a minus 1 by 2 factorial z square plus a into a minus 1, a minus 2, 3 factorial z cube plus etc. So here in place of a you will have minus 1 by 2. So upon using this expansion, so we will get in the simplified form y equal to c summation n equal to 0 to infinity 2n factorial by 2 raised to 2n n factorial whole square minus 1 whole raised to n by p raised to 2n plus 1. So using the expansion y can be, so this is capital Y. Corrections കാരണം capital Laplace transform ആണ് capital Y which denote ചെയ്ത small y is your actual function. So this is the value of capital Y. Now let us take the inverse Laplace transform. Now taking the inverse transform, so y of x will be L inverse of c summation n equal to 0 to infinity 2n factorial by 2 raised to 2n n factorial whole square minus 1 whole raised to n by p raised to 2n plus 1. So when you take the inverse Laplace transform, so here p യുടെ function വരുന്ന, so here you have 2n factorial by p raised to 2n plus 1. So n factorial by x raised to n plus 1 എന്ന് പറയുന്ന that will be the inverse transform of x raised to 2n. So this will be summation n equal to 0 to infinity minus 1 whole raised to n by 2 raised to 2n n factorial whole square. So n factorial whole square x raised to 2n. So this is the value of y of x, or that is the series c times 1 minus x square by 2 square plus x raised to 4 by 2 square into 4 square minus x raised to 6 by 2 square into 4 square into 6 square plus etc. So since y at 0 is equal to 1, so applying this condition you will get again c equal to 1. So therefore y equal to 1 minus x square by 2 square plus x raised to 4 by 2 square into 4 square minus x raised to 6 by 2 square into 4 square into 6 square plus etc. Is the required solution. So this is how we obtain the solution using the previous property we have seen.